Hi everyone, today in this video tutorial, we'll see the contents of the laser Eleksmaker digger kit. We will assemble the mechanics, install the best software, until it comes to the actual engraving. The version I chose has a working area of 380mm for 300mm, then slightly less than an A3 sheet. Additionally, the laser module you will see in this video has a power of 2500 milliwatts, about 450 nanometers, corresponding to a visible wavelength of purple-blue. As usual, in the video description you will find links to the purchase. In my case comes from the Chinese site, Gearbest. You also find it by Banggood. There is not much difference, just check out which store has the best deal. Remember, however, to choose the slower sending mode, you will have to wait about 1 month, but at least you will avoid unpleasant additional costs when delivering. If you opt for fast shipping within a few days, $50 of customs duty will not raise anybody. To you the choice. Before I started, I wanted to recommend buying this great tool, practically indispensable in the home. This is an economical but valid multi-purpose screwdriver 25-in-1. They are included, cutting tips, cross, Torx with hole, of all kinds. With this tool, you will be able to open any cell phone, repair watches, glasses, etc. etc. For those who are interested, you will always find the link to purchase as a description for the video. Let's see the content now. Follow me. Five aluminum rod, 10 acrylic board, 3 stepper motor, 4 corner pieces, 1 holder, 1 power supply, 1 screw box, 1 glasses, 1 control board, 1 laser module, 4 cable, 1 USB cable, 1 bobbin, 4 cable holder, 1 gift. Now that we've checked that we have everything we need, let's move to the assembly in 12 simple steps. For more info, follow the builder's guide to the link I've added to the video description. Follow me. Step 1. Let's take 6 M5 by 12mm screws. Be careful not to pick the smallest 10mm. 6 screws M3 by 14mm, together with 6 M3 nuts. We also reclaim the 6 plexiglass squares as video. We assemble these 6 pieces, as I am doing. Let's put them now, we'll need it later. Step 2. Take 2 pieces of bulky plexiglass, along with 2 of the 3 NEMA 17 motors, 8 M3 screws by 10mm, 2 toothed pulleys, 8 M5 screws by 35mm, 8 wheels, 8 brass knurl nuts, 8 nuts M5 with flange. Prepare all 8 parts by inserting on each screw M5 by 35mm a wheel and a knurled insert. When done, we will enter them into the 8 holes, fixing each one with a washer nut. We will now set up in each of the 2 parts. There is NEMA 17. It is recommended to keep the motor cable connector facing down. Lastly, we put on each crankshaft a pulley. Do not settle them permanently, we will do it when we have put the straps to the final. Step 3. Let's take the piece of laser-backed plexiglass, together with 3 screws M3 by 10mm. Take the aluminum slide in blue color, and let us screw the 3 screws slightly, leaving the 2 central holes free. We put the slide on the plexiglass piece, and tighten the 3 screws. Once finished, we retrieve the 4 knob screws, and we go to the sides of the sled, 2 by the side. Step 4. Take the second piece of plexiglass for the X-axis slide, the last NEMA 17 left, along with 4 screws M3 by 10mm and the last toothed pulley. Now set the motor with the 4 screws, paying attention to the motor cable connector. This time it's best to place it up, as you are seeing on video. Finally, we put the pulley, fixing it lightly. It will be adjusted later. Step 5. We retrieve 8 knurled brass cylinders, 4 screws M5 by 50mm, and the remaining 4 wheels. Now we take the plexiglass piece with the blue laser slide. We will insert here the 50mm screws, a knurled insert, a wheel, and another knurled insert to hold it firm and secure the wheel. We perform the same steps for the remaining 3 screws. Step 6. Take 4 nuts M5 with flange. In this 6th step, we will combine the 2 pieces assembled in 3rd, 4th and 5th steps. Once the 2 plexiglass pieces are connected to the X-axis, we attach them to the 4 nuts with flange. Do not tighten too much, otherwise the plexiglass will creak. Step 7. Let's start with the structure now. We will need the largest aluminum bar, 2 T-nuts M5, along with 2 of the 6 pieces assembled at point 1. Now insert the X-axis lock just finished inside this aluminum bar. We put the 2 T-nuts at the top of the bar, 1 for each end, as you see on video. We now have the 2 plexiglass squares, keeping the screw M3 inside. It will in fact tend to stretch and stop the strap. Step 8. Let us now take all the remaining aluminum bars. For the price paid, we cannot be surprised if anything will get ruined. Let's get it by forming a square. The square bars will go above and below, while the double bars will go to the sides. On these, the X-axis bar will scroll. We recover 4 corners, 8 M5 washers, 8 T-nuts, plus 6 T-nuts for block electronics and legs, and 8 screws M5 by 10mm. Here too, Chinese quality control is the top. Fantastic. We will then use the Allen key 5mm to fix it all. Now, before assembling everything, we have to think where the screws will go, because we should first put nuts M5 inside the aluminum bar holes. If we forgot someone, in fact, we should get half the structure to restore the correct assembly. Let's be careful. At the left bar, just insert 2 nuts M5 into the lower cavity inside. At the back bar, we will insert 2 T-nuts, facing inside. At the right bar, here are 2 inserts, are always at the lower cavity, and always facing the structure. Again on the bar, behind, we will place 4 T-nuts, 2 for the future legs, and 2 to support the electronics, exactly the opposite of the 2 T-nuts already inserted. This bar will practically have 6 T-nuts, while the remaining 2, plus 2, T-nuts, will be put on the last bar. Let's call it front, 2 on the inside, and 2 on the opposite, toward us. They will serve respectively to fasten the corners internally, and the legs of the stand, externally. Prepare all this, insert a washer for each screw M5, and set 1 corner at a time. 1, 2, 3, and 4. Very good. The main square structure is completed. Step 9. Now insert the 2 plexiglass parts, with the 2 motors in the newly assembled structure, 1 on the left, and 1 on the right. In doing so, take 4 T-nuts M5, and insert them at the ends, upwards of the rectangular structure. We can now fix the last 4 square stitch straps. Always remember to keep the screw M3 inward. Now, let's go to the plexiglass legs. They shall be fixed to the 4 corners of the supporting structure by 12 screws M5 by 12mm. For each leg, 2 screws will fasten to the double aluminum bar in the threaded holes, while the 3rd screw will clamp to the T-nut already positioned earlier. We also set the remaining 3 legs of support. Perfect. Step 10. It's time to fix the X-axis bar. Let's take the remaining bar, Take 4 screws M5 by 12 mm, and let's fix it to the rest of the structure. Magnificent! We are almost there. Step 11. We take the last 2 pieces in black plexiglass. Take the card, Mana, 2nd edition. 4 screws M3 by 14 mm. 4 plastic insulating washers. 4 towers M3. And 4 screws M3 by 10 mm. Let's start by inserting 4 screws M3 by 14 mm in the plexiglass, then inserting the 4 plastic washers, insert the electronic card and fix it with the 4 towers M3. Now there is nothing left to place over the remaining plexiglass, aligning the window to the 2 drivers, and close it all, same sandwich, with the 4 screws M3 by 10 mm. We put the ignition key, pressing it on the card. Step 12. To terminate, using 2 screws M5 by 10 mm, we fix the electronics to the structure, keeping all the connectors facing up, as you are seeing on video. If the movements of the trolleys are difficult, perhaps with noisy noise production, do not worry, it will be enough to loosen all 4 screws that secure the wheels, then tighten them again, and the problems will be well resolved. Try to move all the axes, until you reach homogeneity and fluidity in the movements. We now set the laser module on the aluminum sledge in blue. Just tighten the 4 knob screws, and the laser will be in perfect position. Now one of the most important passages is in place. We install the movement belt. Cut the strap into 3 pieces, taking the measurements with the aluminum bars. Better to be a bit abundant and shorten the straps later. Once the 3 pieces have been made, insert one of the ends in one corner, stopping the strap with the square plexiglass. Let us pass the strap under the first wheel, then over the toothed pulley, to finish again under the second wheel. Let's fix it to the opposite end. The first strap is positioned. We do the same work for the remaining 2 straps. Now, align the 3 toothed pulleys, and finally we can tighten them definitively. With the mechanical part we ended here, let's get the wiring now. First we identify the only 3-wire cable. We will place it from one end directly to the laser electronics board at the right connector. Of the 3 wires left, we use the shortest one by connecting it to the X-axis motor connector. We now use the spiral to collect these 2 wires. We terminate by connecting the remaining 2 ends to the electronic board, a connector on the far right and a connector on the far left, as you are seeing on video. Only 2 wires of equal length remain. Let's put an end to the Y-axis motors directly, leaving the right gear for free movement of the axes. We will fix the 2 ends ending with the special, firm cables, and connect their ends to the electronic board, exactly to the 2 remaining white connectors, related to Y-axis movements. Compliments. You've finished assembling this magnificent laser engraver. Now we see the software part, everything needed, up to the first engraving. As for the software part, I deliberately discarded the idea of installing any software on my computer. Chinese, recommended by the manufacturer, Eleksmaker, software that, however, at the time of its installation, requests to disable the antivirus system. I do not add anything else. We will then install the control board, Arduino Nano clone, open source software, GRBL. We then open GRBL's GitHub page for the very least. Let's go down, and in the voice version 1.1 we open the appropriate link. Once I hope the link, download the latest stable version available, in this case 1.1F. I use 1.1, a version, E, but nothing changes. we download the zip point file. Now, before proceeding with the actual software, we have to have it installed on the computer, Java. We then open the Java page and download the latest version for your device, Windows, Mac, Linux, etc. To control our laser web version 4 will be our case. Open the LaserWeb GitHub page, as you will always find links to video description. Let's go to the voice, download, and open the link. Let's go a little bit, and to the voice, LaserWeb 4 binaries, we choose our operating system, in my Mac case, and we open the link. We also download here the last stable version of the program, in my case will be the first entry, .dmg. If you are using Windows, download the version 64-bit or 32-bit eggs. At this point, if you are using Windows 10, you may have finished downloading, but if you have any older version of Windows, or you are using OS X Sierra, you will definitely need a driver for Arduino clones. Eleksmaker, in fact, uses a Chinese Arduino Nano clone, which is not recognized by the PC. This link is for the Mac version. In description I will leave the link to download also for Windows environment. We download the shortcut .pkg, and we do all the installation steps. Let's start the terminal, and type the 2 command lines to remove the old drivers. After this, restart the computer. Now let's start the .pkg file, and run the installation. Restart the computer again. At this point, once the laser engraver is connected to the Mac, the Chinese Arduino should be recognized. We'll find out in a moment. Let's start with the installation. First, let's start with Arduino side. If you do not already have it, go to arduinos.cc and download the latest available version. Well, let's go upstairs, Sketch, Include Library, and click on Add Library from .zip. At this point we open the path of the GRBL file. In my case is in the desk. We go into the GRBL folder, and again select GRBL. Click on Choose to add the library. In my case, an alert reminds me that you've already done this step. Now let's go up. Files, Examples, let's go to GRBL Upload. One click to open the new window. Close the old window. We compile the file to check for no errors. Going to Tools and select as the car the Nano Arduino. Add Mega 328 processor. And as a door, drum roller, we will finally find the 1420 serial. Perfect. We can now click on Upload to load the GRBL firmware on our Arduino Nano clone card. I will not do it, because I have already prepared it before. Now installing the Java program, here too, I've already installed it earlier to speed up the video. We will now arrive at LaserWeb 4, double-click, and let's go immediately to install. Once started, I will show you in a few simple steps how to configure it best for your laser Eleksmaker engraver. Perfect. To configure our laser, we should take you to the settings window. Here we would have a list of machines already pre-configured. Of course, ours is not among them. It does not matter. Click on New Profile, and let's call it Laser Eleksmaker. We click on the symbol more green to add it to the list above. Let us begin. First click on Machine, and we will vary the work area. 400 by 300 mm per hour will be fine. We also show Machine View to have the box marked in the workspace. Click on the magnifying glass, Mark, to display the entire area 400 to 300. close the machine part, and open the setup files. Here, we could retouch pixels and DPI in the future. Close and open the section, G-code. In Start, delete everything and write the M4 command. We will write M18, end code. G28 will be homing's value. The laser PWM value will vary in 256. We set the test power to 100% for a time length of 20 milliseconds. We close the window and open the part application. Here we may like to enable the moves with numipad or gammapad. Let's make sure we have the print start at the bottom left, but any other point can go well. To you the choice. In the room we do not have any cams installed, and in macro we find the 0 return and the laser off. We do not touch anything and go down to Tools. At the entry, Settings, a save, click to export your settings to a file on your computer. For safety we save everything even locally. Now there is nothing else to go up, and click on the orange button with written, Update. Only then can we click the blue button, Apply, and confirm the action. The LaserWeb 4 program is ready and configured to perfection. Let's get in the machine now. Important: make sure you do not have the laser powered with the 12 volt, not having pressed the only button on the card, and then connect only with the micro USB cable. Let's go up, Comms, select the voice USB as connection to the machine, select the right serial port, leave the value of boards 115,200, and click on Connect. If the bottom right of the screen appears, the GRBL firmware found means everything went well, and the LaserWeb 4 program is connected to your laser. With the $check command, you will see all GRBL values. At my first comment on the video, you will find a copy of my values, in case you want to compare them with your configuration. Now that the PC is connected to electronics, we just have to wear protective goggles, make sure there are no other eyes-free people around us, move away from any other room, cats, dogs, or any other pet. Radiations are harmful to everyone. Never underestimate the problem. Once you have your eyes protected, place 3 or 4 sheets of cardboard in the work area. Never leave the empty work area. Connect the 12-volt power supply to our electronics, and press the power button, the only button on the card. Pay close attention, usually at the pressure of that button, the laser module will emit a short laser beam. Do not ever look at the laser beam directly. Now that everything is powered, pressing the key on the laser module power board, the laser will emit a reduced laser beam. This beam will serve as a guide to facilitate positioning on the workpiece and to focus the laser beam. Turning the ring nut below the laser module, we should get a dot as far as possible in the smallest diameter possible. Once ready, let's go back to our LaserWeb 4. Let's go check, and once clicking on the laser test button, the laser will emit a very short laser pulse at maximum power. This will serve to test if everything has been properly connected and set up. Let's now move the axes, both the x-axis and the y-axis. Let's check that the positive and negative movements match the expectations. In my case, the x-axis responded in the opposite direction to my commands. Since I could not rotate the connector in the electronics by 180 degrees, I had to remove all 4 wires from the white connector and reinsert them to the opposite. Having done this, everything has resumed to work perfectly. But let's see now how to do a real test. First, place the laser module at the starting point, at the bottom left of my case, exactly above the card sheet we are going to engrave. At this point, we must tell the software that these coordinates are the 0 of our work plan. To do so, click the button, 0 set, not to be mistaken with the home button. There are two coordinates of two different points. If you are now moving and then click the button, go to XY0, the laser will return to the mark point as 0. Let's get you to the area now, File. Here we will manage the work area by inserting our images. To do this, click on the Add Document button. Look for a black and white two-color image of your choice, and import it by clicking Open. A click on the image will allow you to modify its size, and possibly rotate it. A click on the magnifying glass written doc will make you zoom in on the whole image. My real image will be exactly 100x100mm. The second step will be the setting of our laser. Click on the button, Create Single, keep the item selected, Laser Raster, or Laser Grid. Name, we give, black, but we can do without. The laser diameter will leave it to 0.2 mm, the number of passes will leave it unchanged at 1, and in the voice cut rate, we set the speed. In my case 1000 mm per minute will be fine. The power of the laser, as a first test, we bring it to 50%, or 1.25 watts of power. The rest leave everything as it is, and click on the button, it generates code. At the end, we will have a preview of the path that the laser will affect to affect our image as a whole. By manipulating the lever, simulation, we will see its movement step by step. Now that we have created our gadget, with a power of 50% and a speed of 1 meter per minute, we go to the section Control. Let's go back to 0, for security, and click on a work start. The laser will then begin to engrave the selected area with the selected image. If something is going to go wrong, a click on Abort Work, block the laser movements. Even the Start button work, it will pause work if you want to stop the engraving, to cool the laser module, for example. In case of problems, however, act on the only button on the electronics board, which will eliminate the 12 volts applied to the laser itself. It may happen that something goes wrong, especially on the first engravings, so be ready to act on this last physical key, if you need it. Always with the protective glasses I wear, the safety first of all, I just have to wish you a good job, showing you some my initial test. As always, if the video you liked, leave me a like. If you have any doubts or questions, leave me in the comments below, and if you are not yet subscribed to my channel, do it right now, so that you will not miss the upcoming releases. In this first test, I wanted to try various combinations of laser power and speed of movement. The tests were carried out on a lightweight blue cardboard. In the first 3 tests, I maintained a speed of 2 meters per minute, finding that with a laser power of 50%, then 1.25 watts, the sheet was not even marked. By dimming the speed at 1 meter per minute, instead, the power of just over 1 watt is enough to engrave the card. The first test at the bottom left is the fourth test at the top right. The first has dual power of the laser, but was used at double speed of movement, achieving the same results. So, for those who have a low wattage laser engraver, do not despair, just get off with the speed of movement, and you will get the same results I have. Was not the patience the virtues of the strong ones? In this 6th and last engraving, such a speed as low as 1 meter per minute to the maximum power, he punched the sheet in multiple points. We are talking about a 200 gram x square meter. Obviously, if I had chosen a cardboard of the same grammage but of white color, at the end of this test, it would remain white candy, even with a maximum power of 2.5 watts. As you have seen from my first tests, the materials that can be affected are many: paper, cardboard, wood, textile, crackers, patient, even mirrors. You can engrave leather belt or wallet, etc., etc. Some changes are added or needed, others I will go to do soon. In the detail added to the laser module, a printed support in 3D fan door. This mount will hold me a 40 to 40 millimeters 12-volt fan. It is connected, for simplicity, in parallel to the laser dissipation fan. I connected the negative wire to a free pin of the laser card, while the positive wire directly to the positive of the other vent. This airflow will guarantee me a clean laser engraving and remove from the smoke. This smoke generated by the fusion of the engraved material, in addition to plunging the laser beam itself, can deposit on the collimation lens of the laser, and, for long, damage the laser itself. I also printed, with my 3D printer, a larger ring, which will help me and make the work easier during the focus. Thanks for your vision, stay tuned, bye bye, you see the next video.